3.4 vectors and dot products. So definition of a dot product of two vectors u with components u1, u2, and a vector v with components v1, v2. So the dot product we indicate with a dot to distinguish from the scalar product we did earlier, and that is a number which you get by multiplying the components u1, v1 plus u2, v2. So this product is a scalar or a number, not a vector. Properties. Let u, v, and w are vectors in the plane. And c is a scalar or a number. So number one, if I multiply these two vectors, u times v, with a dot product, is the same if I multiply them in this order, v times u. Number two, if I multiply the zero vector with a certain vector v, the product will be number zero. It's the number zero. Number three, if I have a dot product with u and v plus w, that is the dot product of u and v plus the dot product of u and w. Number four, v times the same vector v is equal to the magnitude of v squared. Number five, c times the dot product of u and v is equal to cu times v, which is the same as u times cv. Example, if I have two vectors, 4, 5, components 4, 5, I want to multiply by another vector with components 2, 3. This is called dot product. This is called a dot product, and we multiply the corresponding components of 4 times 2 plus 5 times 3, and that is 23. Okay, another example. If I have a vector u with components 1, 3, a vector v with components 2, negative 4, and a vector w with components 1, negative 2. A, find u times v and then times w. Now notice the first part, this part here, that will be a number or a scalar. When you multiply by a vector, then you'll get a vector. Okay, so let's start with finding what is u times v. That's the dot product. And so u is 1, 3, dot product with 2, negative 4, and that is equal to 2 minus 12, so negative 10. And then we can multiply this dot product, which is a number, times w. So we're going to have negative 10, and w is 1, negative 2. So we have negative 10, 20. And that is a vector. These are the components of that vector. Part B. Let's multiply u dot product with 2v. So that is, according to our properties above, it's the same as 2 times the dot product of uv So that is 2. We already have the dot product of u and v, that's negative 10. So the result is negative 20. Okay, let's talk about angle between two vectors. Angle between two vectors. So let's draw a picture. We have some vector u and another vector v. We want to know how to find this angle, call it theta, between them. So we have a formula that gives us the cosine of the angle between two vectors as a dot product divided by the product of their multitudes. So this is our formula. Let's have an example. Of course, if you find cosine of the theta, you can find the theta itself. Find theta between vector u with components 4, 3 and vector v with components 3, 5. So first we're going to find the cosine of the angle. Let's write down the formula. This is dot product. And here, this is a regular product on the denominator because those are numbers. So we have 4, 3 dot product with 3, 5 over component. The magnitude of u is, can we find that? Square root of 4 squared plus 3 squared times the magnitude of v, 3 squared plus 5 squared. So the dot product here is 4 times 3, which is 12, plus 3 times 5. So that is 12 plus 15, 27. And here's square root of 25. Is that right? 16 plus 9, 25. And this is square root of 34. So we have this expression. If you want to simplify it, you could. We don't have to. That's 5 square root of 34. But now to find the angle theta, we need to do the inverse of cosine of that number. So you can just type this up. And that is approximately 22.2 degrees. So this is the angle between the two vectors. All right. So this formula, we have the angle between the vectors. We can write it in alternative form. So alternative form of the dot product. And that's the same formula that we have here for the angle between two vectors. But this time I'm going to write it as u times v equals magnitude of u times magnitude of v cosine of theta. So note that magnitude of u is always positive. Magnitude of v is always positive. So the sign of cosine will determine the sign of the dot product. Okay, so let's write this down, that the sign of our dot product u times v depends on the angle between the vectors. So if the angle is acute, then cosine is positive, the dot product is positive. If the angle is obtuse, then the cosine of obtuse angle is negative and the dot product is negative. All right, special case, when the angle between the vectors is right. So we have a definition for two vectors that are orthogonal. We say the vectors u and v are orthogonal if the dot product of u and v is 0. But you know the dot product will be 0 when cosine of the angle is 0, and that is when the angle is pi over 2. So if the angle between two vectors is 90 degrees, then the vectors are called orthogonal. And we can determine whether they are orthogonal or not without drawing the picture, just by calculating the dot product. So here's an example where the vector u is 2, -3, and another vector v is 6, 4. And the question is, are they orthogonal? Are they orthogonal? In other words, is the angle between them 90 degrees? All we have to do is calculate the dot product. So 2, -3, dot product with 6, 4. So we multiply 2 times 6, 12, minus 12, it is 0. So if the dot product is 0, then they are. Yes, they are orthogonal. And that is the end of the lecture.